Alright, so this is another one where we are going to be handling a problem where we're given factorial and we're going to turn it into something else. In this case, pseudocode. So I have A, B, C, D here, and in problems like this, the best thing to do is first to think about what the result should be. So for instance, given a 3 factorial, we should get an answer of 6. Using that to guide us, we should be able to put 3 in for 3 for n here, and in each case we should have returned as 6. So let's go ahead and test that out. We're going to do 2 answers. Let's see which ones line up. Alright, so the first one, saying that n is 3, we're going to either return it if it's less than 1 or return this expression. Alright, so let's get started. If n is less than 1, it's not. So let's go ahead and return n, which is 3, times the factorial of n. Now, given that, we go into another function call where n equals 3. It's not less than 1, so we're going to return 3 times the function call of n. And you know, you can already see the issue here. Because we're just going to keep doing that forever. As you might notice, doing the same thing forever and ever is not really the same as getting the result of 6. So we're going to move on from that. Okay, next one. Alright, so defining something where n is 3, we now have a second variable called product. So let's go ahead and get that product in there. Equals 1. We're going to repeat n times, repeat 3 times product with n times the product. So let's say we're doing that 3 times. So we do n times the product, which is 3. Do it a second time. N times product gives us 9. And we do it a third time. And that gives us a 27. Because each time we've done n times the product. And then we return product, which is 27. Which you may notice is not 6. So it's not B. I guess I'll mark out A also. Moving on down, let's try this one. Actually, 2 answers. Okay, we got it. We got 2 answers already. Yeah, and you can go ahead and finish this up if you like. N equals 3, and then in this case we're going to go do 3 times the factorial of 3 minus 1. So it means we're returning 3 times factorial of 2, and minus 1 is 2. So then on the n equals 2, 1, we go and return n times factorial of 1, which means we're going to check it with n equals 1, and it's going to return 1 times the factorial of 0. Now, in that case, we get to the point where n is less than 0. Right here. N equals 0. N is less than 1, meaning return 1. So it means 1 goes into this value here. So if we're doing that, it's going to be 1 times 1, which equals 1. And that's going to go up here. 2 times 1 is 2. So that's going to go up here. 3 times 2 is 6. So that means that one's good. And we can work out this last one. We can work out this last one now, where we're going to have factorial of n. So that's still n equals 3. The product equals 1. X equals n, which is 3. And we're repeating n times, which is 3. So 3 times in a row, we're going to go ahead and set product equal to x times the product. Okay, x is 3, product is 1. We're going to set product equal to 3 times itself, which is 3. And then we're going to change x to be x equals x minus 1. So that goes from being x equals 3 to x equals 2. Okay, we've done it once. Now we're going to do it a second time. And we have product equals x, which is 2, times the product, which is 3. So product is now 6. X equals x minus 1, so minus 1 here. Okay, and now we repeat our third time. Product equals 6. And so it's set equal to x times the product. X is 1, the product is 6. 6 times 1 is still 6. Then x equals x minus 1. So that makes it 0. And now we've repeated it 3 times. You can also see that because I made 3 x's here, 3 cross-outs here. And lastly, we return product, which is right there. And yeah, that's as it should be, a 6. So in the end, these are the 2 ones that worked. The 2 ones that included this something minus 1 part. Alright. And the parts that did not work did not have that. There's really no difference between the 2 other than that. Okay. And that's how we can check it. Basically what we did was we knew what we were supposed to get. We fed that data in, we tested it, and looked to see if we could get that data again. One of our cases, we had what was called an infinite, not exactly an infinite loop, but an infinite loop idea. Remember how when we started loops, we first did it this kind of way, where we just kept calling the same method over and over again? Kind of like that, except we didn't have any way of stopping it. Because, well, we did have a way of stopping it, just we didn't really have a way of stopping it, because it was constantly going to be calling the same value, and it would never get to less than 1. This one, it did finish, but it finished with a 27, which is far above the 6 that we needed. Alright, then, lastly we tested out these 2, found that both of them equal 6 at the end. I erased my work for this one, but hopefully you saw it, or you can go back and look at that work again. Alright, and that's how we would solve a problem like that.